This video is for the guided notes worksheet that is available on Canvas. We're going to go through these problems together and fill them out relatively quickly since we've already done a lecture on this material. This is just more examples of problems. So let's go through this. The first thing that we're going to talk about are the properties of exponents. We have this in a previous video. We're just going to go through this quickly. When we multiply similar bases in this first expression, that is to say both b and b are the same in the base of these exponential expressions. When we do that, we keep the same base, but we add the exponents together. Maybe I should blow that up a little bit. There. In our next rule, when we raise one power to another power, this is called the power rule for exponents. We multiply the exponents. And going through the rest of these, when we have a product raised to a power, we can raise the individual factors to that power. When we have one base to a power divided by another base to a power, we, instead of adding, subtract top to bottom. When we have a fraction raised to a power, much like this product here, we're simply going to raise the individual factors to that same power. B to the 0 over here on the right side, that's equal to 1, provided b is not 0. B to the negative 1 power is 1 over b. B to the negative n is 1 over b to the n. And 1 over b to the negative n is 1 over b to the n, which is just b to the n. So basically these last two rules simply say that if you have a negative exponent in the numerator, you can take the reciprocal and rewrite it with a positive exponent, and vice versa. If you have a negative exponent in the denominator, you can rewrite it in the numerator with a positive exponent. So that's the review of the exponential properties or rules. And then we just have a few examples here that we're going to run through quickly. Using, let's see, maybe we should number these here. Let's see. Rule 1, 2, 3, 4, 5, 6, 7, 8. Using rule number 2, this is negative 2 cubed times x cubed times y to the negative 2 cubed. Negative 2 cubed, or negative 2 times itself 3 times, that's negative 8. This is just x cubed. And then we'll use rule number 2. Oops, sorry. This is rule number 2. The last rule I used was rule number 3. And so I'm going to take that y to the negative 2 raised to the negative 3 power, and that's going to be y is equal to negative 2 times 3, so that this is negative 8x cubed, y to the negative 6. And if we do want to rewrite this without any negative exponents, we can say that this is negative 8x cubed over y to the positive 6. And that is using rule number 7. So those are the rules that we used. In our next expression, negative 5a squared, all raised to the negative 1, we can break that up as negative 5 to the negative 1 times a squared to the negative 1. And for our second expression, that's going to be a big old fraction here. That's a to the 5th squared over 10 squared. So I'm using a couple of different rules there. I'm using rule number 3 and rule number, whoops, looks like I misnumbered those. Let's see. This is rule 5 here. 6, 7, and 8. And I guess rule 9. I'm off to an awesome start here. Anyhow, there I used rule number 5 as well. Now, when you're doing these problems, you don't have to state the rule. You just need to perform the arithmetic. This is negative 1 over 5, or 1 over negative 5. This is a to the negative 2 times a to the 10th over 100. And then finally, this is negative 1 over 5, 1 over a squared, and a to the 10th over 100. These are all multiplied together, so we're going to multiply across top and bottom. This is negative a to the 10th power over 500a squared. And then finally what we're going to do here is we're going to combine the top and bottom powers of a, which is negative a to the 10 minus 2 power over 500, which is equal to negative a to the 8th over 500. And that's our final answer there. This next expression is simply a matter of us collecting our common factors. So let's see here. As I had suggested before in the video, the best thing that you can do is keep your coefficients with your coefficients, your a's together with your other a's, and your b's together with your b's, man. Buzz with the hive. Buzz, bees. Anyhow, this is 1/2. This is a to the top power minus the bottom power. Watch those parentheses and those double negatives. And then again, the b to the top power minus the bottom power. Cleaning this up, this is 1/2 a to the negative 1 plus 3 times b to the negative 9th, which is 1/2 a squared b to the negative 9th, which is 1 over 2 times a squared over 1, if we write it as a fraction, times 1 over b to the 9th, because of that negative exponent. And then multiplying straight across top and bottom, we have a squared over 2b to the 9th power. And we've rewritten that expression without any negative exponents and simplified it. So that's a quick review of exponents. Okay, let's move on to these polynomials. Here we're just doing simple subtraction. So the first thing that we're going to do here is rewrite this without the parentheses. This is negative 9y cubed minus 2y squared plus 3y. And then we're going to distribute that negative sign. This is negative 8y cubed minus 4y squared plus 1. And then we're going to collect our like terms. So let's see. These are my cubes. And it looks like I have negative 9 minus 8 more. So negative 9 minus 8 is negative 17 y cubes. Then I have for squares, I have a negative 2 and a negative 4. That's going to give me a grand total of negative 6 y squareds. I just have a lone 3y there and a lone 1. And that's my final answer. There it is. In this next example, we're going to simply FOIL. This is going to be the first 2, which is 5 times 2 is 10, and z times z is z squared. That's the f in FOIL, the firsts. Then we have our outers. That's going to be a 5z times negative 3. 5 times negative 3 is negative 15 with a z on there. That is the outer. Then we have the innards. That is going to be 3 times 2z, and 3 times 2 is positive 6 with a z. Those are my innards. And then the last 2 is 3 times negative 3, which is negative 9, and that is the L in FOIL. And then we just have to clean this up by combining our like terms. We have multiple z's, so we have 10 z squareds, or 10 in our z squared pile. Our total number of z's was negative 15 plus 6 more. That's going to be negative 9z, and then negative 9 constants. And that's our final answer. Okay. For 9t minus 2 squared, we're going to take this opportunity to use one of our special forms. Remember that when we have a minus b, something minus something squared, that turns out to be the first term squared minus 2 times the first times the second term plus the second term squared. So here we have 9t squared minus 2 times 9t times 2 plus 2 squared. Here a is the 9t and b is the 2. And if you're not following this, you can always just FOIL that out. There's no problem with rewriting this as 9t minus 2 times 9t minus 2, but this is going to give us 81t squared minus 36t plus 4. And that's our final result. This next problem is a good chance for us to break out the grid method. Let's see, 25r squared plus 10r plus 4. And this is 5r minus 2. And we're going to make a little grid here. Okay. Let's see, so we got 2 rows, 3 columns. And we're going to fill this out as per our discussion in the lecture. And this is going to be 125r cubed, 50r squared, 20r. If you don't recall, what I'm doing here is I am taking the column and row and multiplying them together. So I got 50r squared by multiplying 5r and 10r together. This is going to be negative 50r squared. This is going to be negative 20r, and this is going to be negative 8. And then we have our like terms occurring along the diagonal. And as we scoop them up into our piles, we have 125r cubed. 50r squared minus 50r squared is going to be 0r squared, so those cancel. And oh my goodness, these cancel as well. Negative 20r and positive 20r, and we have minus 8 for our constant. And that's the result. Lastly, we're going to talk about division, dividing. This is division by what's called a monomial. Even though it has multiple variables, it's a single term. And the best way to deal with that is to break it up into multiple fractions. So we're going to break this up over the denominator. This is 27x cubed y squared minus 9x squared y minus 18xy squared, and they're all going to be individually divided by 3xy. Going through here, we'll clean up our coefficients in each case. And what we have here is 27 over 3, that's a 9. Negative 9 over 3, that's a negative 3. And negative 18 over 3, that's a negative 6. We'll then go through here and clean up our x's. That's an x cubed divided by x is going to be x squared. We have x squared divided by x. That's going to be a single x. And we have x divided by x, which is going to cancel. And I'll just cross those out. Moving to the y's, we have y squared over y. That's just going to give us a single y. In the next term, we have y divided by y. Those are going to cancel out. And we're done with that term. And then again, we have y squared over y on the end. And that is going to be y. And our answer here is 9x squared y minus 3x minus 6y. And that's the result from that division. Oops, let me leave that up there for a second. This last problem is divided by a binomial. And we're going to use long division here. We didn't talk much about long division in the previous video, so we're going to go over it here in depth. What you want to do is maybe rewrite this as x cubed plus 4x squared minus 5 divided by x plus 2. That's one way to rewrite it, but we're going to need to do a couple of things here. If we're going to use long division, we got to rewrite this old school using our old division bar. We're dividing by x plus 2, so that's the part that goes outside that little division house there, x plus 2. The other part of this polynomial here, the numerator, that's going to go under the bar here, but there's one more thing that we have to do. Can you guess what it is before I write it? Well, we're missing the x term here, so we got to use a placeholder. I'm going to put plus 0x in there, minus 5. So that's the proper placeholder. And now we're going to go through this. What we need to do is we need to first focus. Whoops, not scribble it out. We need to focus on these leading coefficients, leading terms. So the question is, what do I have to multiply x by to get x cubed? Well, the answer to that is x squared, and this is my x squared column. So that's where I'm going to place that value. And then what I'm going to have to do is multiply and distribute by both of these. Now x times x squared, that gives me x cubed. By design, that's called engineering. We made that happen. And then plus 2x squared as we multiply by that too. And the next thing we need to do here is be really careful and use parentheses and subtract so that we don't do this next first step incorrectly. Now x cubed minus x cubed is going to give us 0, and 4x squared, even though this looks like a plus sign here, don't forget that we're subtracting. So it's actually a 4 minus a positive 2, which is 4 minus 2, which is 2x squared. And then we drop the other terms like they're hot, man. All right. And then we repeat. So let me get a different color because I like to color coordinate like so much. Let's not use that. Let's use this crazy color. Now, the question is, what are we going to multiply x by so that we get 2x squared? And the answer here is 2x. And we're going to distribute again. It's getting a little busy here, but that's going to give us 2x squared plus 4x, again, parentheses, subtract ever so carefully. By design, we're going to get 0 there, and then 0 minus, again, don't forget that even though that's positive, we're subtracting it, and we're going to get negative 4x. And then we drop the negative 5, and we repeat this process like one more time. Like so much funsies. And x times what gives us negative 4x? Well, negative 4 is going to do that. So we're going to get a negative 4x and then a negative 8. Parentheses, subtract. Negative 4x minus a negative 4x is going to give us a 0. And then again, like I'm repeating myself so much, this is a double negative. Those are hard to see. Let me erase that. Let's use a different highlighter there. Lime. Yummy. So that's a negative 5 minus a negative 8, which is negative 5 plus 8, which is going to give us a positive 3. And that's our remainder. And we deal with that remainder in a special way. So this expression, oh, what happened? Okay, well, never mind. The expression x cubed plus 4x squared minus 5 divided by x plus 2 is equal to the quotient x squared plus 2x minus 4 plus the remainder over the divisor. So this is called the quotient. Oh, that's hard to see. Let's go with some pastels, man. This is the remainder and this is the divisor. And that's it. Some long division, man. Okay, that's the end of our guided notes here. What I would suggest you do is, even though I've done all of these for you, I'm going to put up a blank PDF of these same guided notes on Canvas, and you should go through these in practice, and obviously you should be doing the homework, but when it comes time for you to review for the exam, you don't want to blast through these handouts as sort of a review sheet, so keep that in mind, that these guided notes can be used as review for the exam and the quizzes, and your first quiz is at the end of week 1.